Hello everyone, my name is Aarohi and welcome back to my channel. So guys, in our last class we learned about broadcasting in NumPy. And today we are going to cover the next important topic, which is random module. The NumPy random module is used to generate random numbers or random data points. Now the question is, why do we need these random numbers? Why do we need this randomness in programming? So let's understand this. So in AI and data science, randomness is used in many places. For example, when you start working with your machine learning or deep learning models, you will notice that every time when we train a model, it usually starts with a random initial values, which is known as weights. And then slowly, with time, your model learn properly. And without this randomness, your AI model won't learn anything. And guys, right now, don't worry if you don't fully understand terms like models or weights. We will cover them later in the playlist. For now, just remember that randomness plays a very important role in AI. And this is not the only case. In AI, there are many other situations also where random numbers are required. And to generate those random numbers, we use NumPy's random module. So now let's see practically how we can use this random module. So open VS Code. So guys, this is the folder, NumPy tutorial folder, where we have done all the examples related to NumPy. So today also we are going to write our example in this folder only. So create one file, click here and name it NumPy Random Example.py. So here we will write our code. So first thing is to import NumPy. Let's write np.random.rand. So this is how you use random module np.random, and then you will write a function name which you want to use. So there are different functions. So the first one is rand. So we want to use rand function of np.random module. This rand function, what it does, let's understand. So with the help of this rand function, we can create an array of random numbers, and those numbers will be uniformly distributed between 0 to 1. Means the random numbers which you are going to get using this function, those numbers will be between 0 to 1. Means number can be equal to or greater than 0, but that number will be lesser than 1. Let me explain you with example. So let's say we have 10 over here. Now let me print the output and then I'll explain you. Print it. Save this file and run it. Python, file name is NumPy Random Example.py. See, we got these 10 values. Okay. And all these values are between 0 to 1. So this is a 1D array of random numbers. Now, let's just copy this from here and paste it here. This time, I want to have a 2D array of random numbers. So in these parentheses, you will write, let's say you want to have 3 rows and 4 columns. So you will write like this. Now you will get a 2D array where you will have 3 rows and 4 columns, and in those 3 rows and 4 columns you are going to have random numbers, and those values, those random numbers will be between 0 to 1. 0 will be included, but 1 will not be included in it. So let's just print it and see. Let me just comment the first one. Now let's run the file. See, you got this. 3 rows, first row, this is the first row, second row, and third row. And in each row, how many values you have? You have 4 values. Why? Because we have mentioned here that we want 4 columns. And all these numbers are between 0 to 1. And you can note that there are no negative value because it will give you a uniform distribution, and every time you will get numbers between random numbers between 0 to 1. So this is what np.rand function does. Now let's talk about the next function, which is np.random.randn. Now let's see what is the difference between this and this. Now let's write 10 over here. The same 10 we are writing over here, and let's print it. Save this. Let me show you the output first, then I'll explain you how this function is different from this function. So clear the screen, Python. This is the file, run it. See, this is the output. Now we have 10 numbers, 10 random numbers. See, there are two things to note here. Most of the numbers are closer to 0. Not all the numbers, but most of the numbers are closer to 0. And second thing to note is that we have negative values also. So this is how this randn function is different from rand functions. Here we have negative values. Values are closer to 0. But when we used this function at that time, we were not getting any negative values, because over here we get values between 0 to 1, where 1 is excluded, but 0 is included. So this is the difference. And over here in this randn function, the values are getting distributed using Gaussian distribution, or you can call it normal distribution. What it is? Gaussian distribution means with a mean of 0 and standard deviation 1. Let me write it over here for you. Mean 0 and standard deviation 1. Okay. So the random values which are getting generated over here, those values are generated using Gaussian distribution. And over here, those random values are generated using uniform distribution. Now, what is uniform distribution? Uniform distribution simply means that all the values will get equal preference. Means no value is preferred over another value. Every number will get equal preference. For example, when we play Ludo, we roll the dice. So there are 6 numbers, right? When we roll a dice, so each number has equal probability that they will get selected. So this is what uniform distribution is. And Gaussian distribution means that most of the values will be closer to 0. Now let me create a 2D array using this np.random.randn function. So let me just copy this from here and paste it here. This time you just need to mention the shape over here. Let's say we want to have 5 rows and 6 columns. Save it and run it. See, we have 5 rows, first row, this is second row, third, fourth and fifth row, and we have 6 columns. And you will see that we have negative values and most of the values are closer to 0. And guys, this is the module we use when we want to initialize the random weights in AI and deep learning algorithms. Now let's see the next function. So the next function is np.random.randint and parenthesis. Here you write one number, this is the starting number, comma, write the largest number. So let's suppose I have mentioned these two things. So this is the starting number, this is the end number. What it means? It simply means that this line will give you one integer random number between 0 to 10. It will give you single number. Okay. So let me just print it and show you. Save it and run it. See, it gave you 3. So one number, one random number between 0 to 10. Now let's say you want to have a 1D array of integers. When do we use this randint function? So when you want to have whole numbers, when you want to have integers and you don't want to have values in decimals, then you can use this randint function. Now here with this we got single random number. Now let's say you want to have a 1D array of integer, write comma and write how many numbers you want. So let's suppose you want to have 6 elements in a 1D array. So you will write 6 over here and save it, and let's run it. See, now you have a 1D array, and in that array you have 6 numbers. So these are the 6 numbers, 6 integers randomly generated between this to this number. So here if you write 2, let's say I write 2 over here, save it. The counting will start from, the random numbers will start from 2. Okay, save it and run it again. See, now you got 6 random numbers. You got a 1D array of random integers. The range of those numbers is between this to this. Okay, so this is how you create 1D array. Now let's say you want to create 2D array. So let's just copy this one, paste it here, and over here delete this and write size equals to parenthesis and mention the number of rows and columns. So let's say you want to have 3 rows and 4 columns. Save it. So this is how you can create a 2D array of random integers. Now let's just run this file. See, you got 3 rows and 4 columns, and the numbers are between this range. So guys, this is how you can use this randint module. You use this function when you want to have integers, random integers. Now let's see the next function, which is np.random.seed, and just write one number over here. Let me explain you what it is. So guys, this np.random.seed, this function is very important in AI. Why? Let me explain you. So guys, as I've told you earlier also, that when we train our AI model or machine learning model, so there are many steps where randomness is involved, like how the data is split. Over there, you use randomness also. And when you train your model, the initial values are set, those values are random, right? So because of this randomness, even if we run the same code multiple times, we might get slightly different results every time. So suppose you get different accuracy every time. Now imagine that you are trying to improve your model and you make some changes in your code, and then you trained your model again, and after that accuracy changed. Now the problem is you won't know whether the change in accuracy happened because your model improved or it is just because of the randomness. So to solve this problem, we use this np.random.seed function. So this function fixes the randomness so that every time when we run the code, we get consistent results. After fixing the randomness, if your accuracy is changing, now you know that that accuracy is changing because you made some changes in your code, and the accuracy is not changing because of the randomness. So this is the benefit of this seed function. So in simple words, we can say that in machine learning or in deep learning or in AI, this randomness can change the result every time we run the model. And by setting this seed value, we can fix that randomness so that every time when you run the code, you get same results. So this is the benefit of this seed function. Now let me show you a simple example of seed function. Comment this. Okay, not comment it, let it be like this only. And here let's create np.random.rand, and let's create a 2D array. I want to create 2 rows and 3 columns. Save it and run it. Let me just comment everything else. Now let's run this file. See, this is the output we got. These are the random numbers. Now let me run this code again and you will see that we are getting the same numbers. See, numbers are same. See, first number is this, and over here also the first number is this. Second number is this, and here the second number is same. So like this, we have the exactly same number, even though we are using a random module which generate random numbers every time. If you used this seed, after that you are getting the same number. If you want to run it again, run it. As many time you want to run it, you will get every time you will get same numbers. Now let's say we are not using this random module. Now what will happen? Let's see. So let me clear the screen, and now we are not using the seed function and run it. So these are the random numbers we got. Now let's run the code again. This time you got different numbers. Earlier this was the first number, this time this is the first number, and this is the second random number, this is the second number over here. So you can see we are getting entirely different numbers. So this is the benefit of seed. With seed you can fix the random number so that every time when you run the code you get the same number. So this is what seed is. And now let's see the next function, which is shuffle. So next function is shuffle. Guys, this is also very important. We use this when we want to give data to our AI model. So every model needs data to get training, right? So whenever you give data to your model, before giving that data to the model, we use shuffle function to shuffle the data so that your model learn in a better way. So I will explain you this with examples. So for example, we have this array, and in this array we have 1 2 3 4. These four elements are there. First I'll show you the simple example, then we will see the next example which will explain you the things in more cleaner way. So for example, we have this array, and this array have 4 points. Now with the help of this shuffle function, use shuffle function. So write np.random.shuffle and write the array name, this array, because we want to shuffle the elements of this array. Now let's print the array after shuffling. Let's run this code and see, this is the output. The actual array is this 1 2 3 4. These are the elements. This is the order of the elements. And now after shuffling, 2 4 1 3. So this is what shuffling does. Now let me explain you the concept of shuffle. Why do we need to shuffle the data with one example? So I am just pasting this. So this is a array data, and in this array 0 means not spam and 1 means spam. Now we are splitting our data. Why we split our data? Because in AI, when you want to train your model, now you divide your data in training set and test set. You train your model on a training set first, and then you test your model on a test set. So over here I have mentioned that train and use the first 6 examples for training and remaining examples for test. So the first 6 sample means this is the first, second, third, fourth, 5, 6. So these are the samples I want to use to train my model, and these 2 samples I will use to test my model. Let's print what data we have in training and what data we have in test. Let me just run this file. So we have these examples in training and these examples in test. Let me just copy it from here and paste it here. So for training we have these samples, and for testing we have these samples. Now if you will note that while training the model, we gave more examples related to not spam, and we gave very less examples related to spam, right? So our model will learn more about not spam, and it will learn less about spam emails or spammy messages. And in test set, we are giving it these examples. But Our model learned more about this, and in test set we have these examples, but in training set these examples were very less, so our model didn't learn much about these examples. So in this scenario your model will not perform good, your model's accuracy will be less. This is the example without using shuffle. Now we will do the same example with shuffle function. Okay, so this is the example. This is the example without using shuffle function. Now we will use the same data, okay, same data, and we will use shuffle function with it, and we will see what is the benefit of doing that. So example with shuffle function. So I'm just pasting the code over here. See, let me show you what I have done. See, I have imported the NumPy. So this is the same data array. Then we used np.random.shuffle and we shuffled this array. Then in training, I'm saying take the first 6 examples after shuffling this array. Shuffling means it will rearrange the elements, right? After shuffling, we are taking the first 6 elements for training and remaining for testing. And let me just print the training set and test set so that you will know after shuffling what kind of records we have in training data and what kind of records we have in test data. So let's save it and run it. See, earlier this was our training set and test set. Now, see, in test set we have both the examples, and in training set also we have equal examples of one class and equal example of zero class. So over here your model will learn better. Now this data is better for training, right? So your model will learn more and the accuracy will be improved. So that's why we should use shuffle function. So guys, this is all about random module. So I hope this video is helpful, and guys, the link of this code is mentioned in description section. You can get this code from there. And guys, if you like my content, please like the videos, share it with your friends, and comment if you have any suggestions. Thank you for watching.